Questions about these two probability problems from Chapter 10D come up every single year. So let's have a look at question 10 first of all. Right, a hand of 5 cards is dealt from a normal pack of 52 cards. Find the probability that the hand will contain no aces. So when you dish out a card from the deck, you can either get an ace or not an ace. The chance of getting an ace is on the first card being dished out is 4 in 52, or not being an ace is 48 out of 52. Now when you've dished out one of the cards from the deck, so you start with 52, when you've dished out one card, you're going to have 51 cards. And remember, you dish out not an ace first of all, then you can dish out an ace or not an ace on the second card that is given out. Now, not an ace at this point here, because I've given out not an ace first of all, there's 47 not aces left in the pack out of the 51 cards. We're looking for no aces, which means this will happen every time. 46 out of 50, 45 out of 49, and 44 out of 48. And what you would do is multiply those out to get an answer. There's another way of doing this though, and that's with counting methods. Okay, so what you would do with counting methods is you would look at the number of different 5-card deals, which is from 52, choose 5. I want to know the number of ways of doing that. And then I want the probability of no aces, so I want to work out the number of ways no aces can be done. And that's from 48 cards. What I would do is choose 5. So how many different ways are there of choosing no aces? From 48 cards, I want to choose 5. So either of these could be punched in the calculator and worked out. So we can do 48 over, that one's going to take ages to do, so shift divide 48 over 52 multiplied by 47 over 51. Ah, we get that, or we can go through advance NCR 48.5 over NCR. I'm just going to type it in on my keyboard, 52.5. Right, so exactly the same thing there. Okay, now for part B, what we're looking for there is at least one ace, which means no aces. So we're simply going to do one, take away this answer here, which is 3, 5, 6, 7, 3 over 5, 4, 1, 4, 5. So we'll do 1 take away 3, 5, 6 rather, not 7, over 5, 4, 1, 4, 5, and that equals that. So I've forgotten my mouse at school today, so I'm using the pad on the computer, and it's a bit of a nightmare. 18472 over 54145. Okay, part C, the ace of spades. Okay, so the way I think about that one is that if I'm getting the ace of spades, what I want is the total hands. So that's 52, choose 5. So the total number of ways 5 cards can be chosen from 52, because again, this is a probability. And what we're going to do then is look at the number of ways of getting the ace of spades. And what that represents is from 51 cards, we're going to choose 4 cards because the ace of spades has been chosen. Okay, so let's do that. So NCR 51.4 over NCR 52.5. And we get 5 on 52. Okay, so what we now are going to look at is the ace of spades, given that there is at least one ace. Okay, and basically to do that problem, it's just this probability is going to be the denominator and this probability is going to be the numerator. Okay, so we've got already the numbers we need for that. So it's going to be the probability of the ace of spades, which we just worked out, which is 5 over 52, over at least one ace, which is 18472 over 54145. Okay, what does that equal? That divided by this thing. Okay, and we get 20825 over 73888. All right, so yeah, that's just the conditional probability. So what we're doing is we know that there's at least one ace. So we basically just shrink the sample size by that amount there over the chance of getting an ace of spades. So it's the probability of that over the probability of that. All right, now let's go to question 11. Okay, a committee of 3 is chosen to be from a group of 4 men and 5 women. Find the prob that the committee contains all women. So when you choose between one of the 9, you're going to get a woman or not a woman. The chance of getting a woman, so we've got 5 in 9. Then we can get a woman, which is 4 in 8. And then a woman, which is 3 in 7. And we simply multiply those values together. Now, that's one way of doing it. The other way of doing it is with counting methods. So what we look at is the number of ways that we can make a committee of 3. So that's from 9, choose 3. And all women means from 5, choose 3 women, multiplied by from 4 blokes, choose none of them. Okay, so 4 choose 0 is 1. So that's simply going to be NCR 5.3 over NCR 9.3, 5 and 42. Okay, so you can either use a tree diagram or counting methods. Okay, the probability of at least one woman. Okay, so again, I'm going to use counting methods on this. So from 5, choose, actually, what at least one woman means not all men. Okay, so 1 take away all men. So all men, so there's 4 men. So from 4, choose 3, multiplied by from the 5 women, choose none of them, over 9C3, the total number of ways of choosing 3 from 9. And why I'm doing 1 take away that is this is the chance, this one here is the probability of getting all men. At least one woman means not all men, so we're going to remove that from 1. Okay, so that's going to be 1 takeaway. NCR, let's force the brackets. 4, 3, don't know whether the brackets were needed there, but not taking any risks. 20 over 21. Okay, part C, exactly 2 men, given that there is at least 1 man chosen. All right, at least 1 man chosen means not all women. So we can take care of that condition, the given condition. So not at least 1 man is not all women. So we're going to do 1 take away all women, which is 1 take away 5 on 42, which is equal to 37 on 42. So that's going to form the denominator. Okay, so we shrink kind of the sample if you want to imagine that. So given that, okay, we use that to shrink it down, and exactly 2 men. Okay, so exactly 2 men is going to be, so here's the two men calcs. Exactly two men means from the four guys, choose two of them, multiplied by from 5, choose one, all over 9, choose 3. All right, so on the calculator, that would be done by doing NCR for 2 times 5, choose 1 is 5, so I'm just going to write that as 5, all over NCR 9, 3 is 5 on 14. Okay, and so then to finish this off, we'll just simply grab that and divide that by 37 on 42. We get 15 on 37. Okay, so there's one way of approaching these problems. All right, so follow up any questions you've got on these, and if you want to sit down and chat about them further, don't hesitate to ask.